So, hello everyone. In our previous lecture, we had discussed about the various topics of the chemistry. In this lecture, we are going to discuss about the organic chemistry. Okay, so let's start. So, the first thing is, what do you mean by organic chemistry? What do you mean by organic chemistry? Basically, organic chemistry is the branch of chemistry focuses on the study of carbon containing compounds, their structure, properties, reaction, and the way they succeed and way they interact with each other. Okay. So basically, here we have to deal with something. First is carbon. Second one is molecule. Third one is hydrocarbons. Then homologous series. Then functional group. Okay, so these are the some topics which we are going to discuss in this lecture. Okay, so let's start. So as we have known that the organic chemistry is a branch of chemistry which deals with the study of carbon containing compounds. Carbon containing compounds means if this is a compound which is a mixture of two or more element, okay, which we have discussed in a previous lecture. If this is a compound, okay, and it's containing the carbon, then studying this compound comes under the organic chemistry. Got it? So we can say any compound, and compound is a group of two or more elements. Okay, if any compound containing the carbon and we have to study it, then we will study it about the topic of organic chemistry. Get it? Now let's understand few things here. First of all, we have to study about the hydrocarbons. Then only we will be able to study all the facts covering under the organic chemistry. So basically, before hydrocarbons, we just need to recall some phenomena which we have studied in our previous lectures. Okay, and what are the implications on these phenomena on the carbon? Remember one thing I have shared you: ionic and covalent bond. And do you also remember the octet rule? I hope you remember. Got it? So what was about it? Actually, in octet rule, which was given by Mr. Kossel and Mr. Newton-Lewis. I have told you the full name in a previous lecture. Okay, just remember the Kossel and the Newton-Lewis were the ones who gave the octet rule, and octet rule states that if this is an atom and these are the orbits surrounding the center of the atom, then these orbits and the last one orbit must have 8 electrons. Must have 8 electrons in the outermost shell. Okay, if the atom does not have 8 electrons in the outermost shell, then it will be unstable. It will be unstable whether the electrons are high or low. But if they are not in the number of 8 in the outermost shell, then the atom will be unstable. Okay, it was dictated by the octet rule. Okay, so what I had told you in the previous lecture, that there are two types of bonding to balance this equation. First is ionic bonding. Let me recall it for you. First is ionic bonding, in which we said complete transfer of electrons First is ionic bonding, in which there was a complete transfer of an electron from one atom to atom. For example, we said that if atom 10 having if atom A having 10 electrons and atom B having 6 electrons, in this case it has 2 more, in this case it has 2 less, so A will give 2 electrons to the B, and then they both will have 8 and 8. Okay, and then you can say they are the stable ones. Okay, second one is our covalent bonding. In covalent bonding, I had told you there is no complete transfer but mutual sharing. For example, we had taken an example of chlorine. Here I am giving it the name of A and B respectively. Okay, 1, 2, 3, 4, 5, 6 and 7. Similarly, 1, 2, 3, 4, 5, 6 and 7. In this case, A having 7, this case B having 7. Okay, and they both are in deficit of 1 electron. Got it? So in that scenario, they both could share their 1 electron with each other. So in this case, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Similarly, 1, 2, 3, 4, 5, 6, 7, 8. So here now the electrons are becoming 8 and 8. 8 and 8. That I had told you. Remember? So the similar thing will applicable here also. Got it? But in the case of carbon, remember one thing, that carbon having four electrons in the outermost shell. That carbon having 4 electrons in the outermost shell. So there are two scenarios. First, lose all 4 electrons. Second, gain 4 electrons. Okay, in this scenario, two things happen. Like if suppose this is a carbonic atom, okay, and this atom having 4 electrons in the outermost shell. In the first scenario, if carbon decided to lose all the 4 electrons, then what will happen? It require high energy. Okay, and carbon could not lose 4 electrons easily. So first scenario is get failed. Second scenario, gain over 4 electrons. Remember, in the law of conservation of charge, I had told you that the positive should be equal to the negative to get the stable condition. Okay, so if carbon gained 4 electrons from someone, then its nucleus not having sufficient positive charge. Okay, so in this scenario, if this is a carbon atom and it decided to gain 4 electrons, okay, but its nucleus, this part, does not having sufficient positivity or sufficient protons, then the atom will become disabled. So this scenario is also get failed. Okay, so here we have discussed about the outermost shell electrons of the carbon and what carbon can do for them. First is lose all 4 electrons. Second, to gain 4 electrons, I have told you what will happen if carbon does any of these things. Got it? So how carbon handle this situation? But remember one thing, here is one interesting fact, that despite of these things, despite these things, carbon having largest number of bonds. Despite all these things, carbon having largest number of bonds, means carbon does largest number of bondings with other atoms or other elements. How does it possible? It is possible because of two main things. Because of two main things, which are catenation. Second one is a tetravalency. Tetravalency. Okay. So through first means through catenation, carbon can does or self-linking. So basically you can say through catenation, carbon could make bonding with other carbon atoms. Okay, or it is also known as self-linking because carbon and carbon and carbon and carbon. So carbon is getting merged with the carbon, so that's why it is known as the catenation. Catenation. So it's a first property of the carbon. Through this, it made it large number of carbonic atoms, or sorry, carbonic bondings. Catenation. Next one is a tetravalency, or you can say tetravalent. Okay, because it having four electrons in the outermost shell. Okay, so it could make bonds with other elements by sharing. Got it? So it is the second property. Because it having 4 electrons in the outermost shell and it required 4 more. So as we had discussed, it could not gain, it could not lose. So it started sharing with other elements. Okay? And sharing comes under covalent bonding. Remember? And here we are going to discuss about 3 types of covalent bonding known as single, double and triple. Got it? We are going to discuss about them one by one. Okay? So these are the basic properties of carbon through which it makes this number of carbonic compounds. Okay? So basically, as you can see, hydrocarbons is basically group of hydrogen plus carbon, and these known as hydrocarbons. These are the organic compound of hydrogen atom and the carbon atoms only. Remember, only hydrogen and carbon. Simplest class of organic compounds and serve as the foundation for more complex molecules. And remember, their first product is a question is coming in the exam and it's asked you first product of organic chemistry or hydrocarbon, then it is a urea. It is a urea. Okay, now let's move forward. Hydrocarbons can be classified into two main types, saturated and unsaturated. Okay, saturated and unsaturated. Like saturated hydrocarbons. These hydrocarbons are also known as alkanes. So you can remember, if there is written down alkane, then it will be a saturated hydrocarbon. So remember this thing. Got it? Alkanes having single bond, basically like this type. Single bonding. Okay, or also you can make it like this. This one. Okay, and general formula is this one. Got it? However, the formula is not generally coming to exam, but you can remember it. Okay, so the line between the atoms, atom 1, atom 2. So the line between the atoms shows that which bonding it is. If line is generally like this, it will be a single. Line is like this, it will be a double, and line is like this, it will be a triple. Okay, so just make these lines so that you can remember it for a long time. Okay, so here we have discussed about alkane, and alkane is a single sharing, so it means line should be like this. Got it? Now come to the next one. Alkanes can form straight chains, branch chains, and even cyclic structure. Even cyclic structure, you can say this is a straight chain. This is a branch chain. Let me write down here straight, then branch. Okay, and if it's like this one, then this is a cyclical form. Remember it. Okay, if it's like this, if it's like this, if it's like this. So the first one is a straight example, second one is for the branch, and third one is for the cyclic. Got it? Now, isomerism occurs due to the different arrangements of carbon atoms leading to the different physical and chemical properties. So here we have learned about the isomerism. What do you mean by it? We will learn about it in a little bit. Okay, and also we will learn about some facts. We will learn some facts about the molecules. Got it? Now, unsaturated hydrocarbons. The unsaturated hydrocarbons contain at least one multiple bond between carbon atoms, making them unsaturated with hydrocarbons. What do you mean by it? Let's understand. First one is our alkene. First one is our alkenes. Okay, and alkenes are basically double bond. Here, just read this one. Unsaturated hydrocarbons contain at least one multiple bonding. Multiple bonding here stands for more than one pair. More than one pair. So here we have noted down that there is only one pair between the atoms. Okay, but to be declared as unsaturated, there must be more than one pair, or you can say at least one multiple bond between carbon atoms. If there is no multiple bond, then it is a saturated one. But if there is multiple bonding, then it is a unsaturated hydrocarbon. Got it? Now let's move forward. So first type we having alkene, and alkene basically stands for double sharing. It stands for double sharing. Okay, so simply you can say this one. Simply you can say this one is a example for alkene. Got it? So it is also in the form of straight line. Thereafter you can say branch form. or this is a straight line example. This stands for branch form, and this stands for cyclic or cyclical. Okay, so it can also form these forms. Got it? And the formula is CnH2n. You can note down it. Now let's move forward. It is a alkene. Alkene is also the unsaturated and having at least triple bonding. At least triple bonding must be there so that you can declare it as a alkene. Formula is CnH2n minus 2. You can note down it, and it can also be a straight chain like this, branch like this, and cyclic like this. Got it? So it is about the alkene. All right. Now let's come to the topic which I have told you. I will tell you in this session is the molecule. First is a molecule. Remember, I have given you a general example of molecule or general introduction of the molecule like atomic group. Okay, like if it is atom, another atom, another atom, then they all combine together. So these are the atoms, atoms, atoms. But this is the molecule. Got it? I had told you, right? So basically here we are going to discuss some general introduction about the molecule. All right, the molecules. First point about the molecule is that constitute same type of atom. Okay. Second point is can be classified into monatomic, diatomic, and polyatomic. Okay. And the third point is molecules in compound joined together in definite proportions and constitute different type of atoms. Okay, so the first condition of constitute same type of atom is only applicable to elemental form. Elemental form. So basically you can say if a molecule is formed under the element, and we know that element constitute only single type of atom, then only the molecules formed inside the element will only have same type of atom. Got it? Second condition is that the molecule can be classified on monatomic, diatomic, and polyatomic. Monatomic is a condition when there is only one atom inside the molecules. Diatomic stands for two atoms inside the molecules, and polyatomic stands for more than two atoms inside the molecules. Got it? And thereafter, the molecules in compounds join together in different proportion and constitute a different type of atom. Definite proportion is a derivation of two laws of conservation of mass. Okay, and second one was definite proportions. I hope you remember these laws. Okay, I had told you in these sessions. So these laws are basically implied in this situation. Like I have told you, compound is a group of element. Compound is a group of element. Got it? So basically, in the compound form, you can say there are more than one element. So the atoms and the molecules formed inside the compound may constitute different atoms. Okay, so this is about the molecules. Got it? This is about the molecule. Second thing which we should note down is some properties regarding unsaturated and saturated carbon compounds. Okay, so for the saturated hydrocarbon, basically here S represents hydrocarbon. Got it? Now for saturated hydrocarbon, second is for unsaturated hydrocarbon, and the condition is combustion. Okay, or for your better understanding, you can write it down like this: combustion. Okay, and in a previous lecture, I had told you about the combustion. Okay, so I hope you remember it. Then unsaturated. Okay, for saturated hydrocarbon, it will remove CO2, heat, and water. CO2, heat, and water. Okay, and it will burn with clean blue flame. Clean blue flame. Got it? But if air is limited, then with sooty flame. Okay, so remember, during the combustion for the saturated hydrocarbon, it will remove CO2, heat, and water, and saturated hydrocarbon will be one with a clean blue flame. But if the air is limited in which it is burning, then it will burn with sooty flame. Got it? But in the case of unsaturated hydrocarbon, it will burn with yellow smoothie flame. Got it? It is a case for unsaturated hydrocarbon during combustion. Got it? Second is hydrocarbons with oxidation. With oxidation, and you can say reduction. Okay, what do you mean by oxidation and reduction? This is the first question. So if A and B is getting combined and formed AB, okay, so basically you can say during the oxidation, if product get oxygen or O2 during reaction. Okay, what do you mean reduction? If product loses oxygen or O2 during reaction. Okay, so suppose in this scenario, if A plus B getting oxidized and forming, A and B underwent a reaction and formed AB. If AB get oxygen, then it is example of oxidation. But if AB loses oxygen, then it is example of reduction. For saturated hydrocarbon, during oxidation, it prepares ethanoic acid. Okay, what do you mean by ethanoic acid? We will learn this chapter further. Okay, for this process, we use potassium dichromate, second one is sulfuric acid. Okay, so during this reaction, we use potassium dichromate and sulfuric acid. Basically, potassium dichromate used for oxidizing the reaction, and sulfuric acid used for acidify the solution. Okay, so basically you can say the ethanol reacts with potassium dichromate plus sulfuric acid, and their outer product is ethanoic acid. Okay, so in this scenario, ethanol is the base for ethanoic acid. Okay, potassium dichromate basically used for oxidizing the reaction, and sulfuric acid basically used for acidify the reaction. Got it? So it is an example of oxidation during the saturated hydrocarbon. Now let's take an example of reduction for unsaturated hydrocarbon. Reduction for unsaturated hydrocarbon. Okay, so basically in this process, the unsaturated HC reacts with dihydrogen, okay, in presence of catalyst like nickel or platinum. Okay, so this is an example of unsaturated hydrocarbon reaction of reduction, in which unsaturated hydrocarbon reacts with dihydrogen in presence of catalyst like nickel or platinum, and basically it is done for converting vegetable fats into vegetable ghee. Okay, vegetable fats is harmful. Vegetable fats are basically harmful, and vegetable ghee is non-harmful of nature. Got it? So this is about the unsaturated hydrocarbon. So in this lecture, we have covered some aspects of the organic chemistry. In our next lecture, we will proceed with some other facts of the organic chemistry. Till then, thank you.